Hi everyone. In this video, we'll be solving one DSA problem which was recently asked in Amazon online assessment round. So the question says that given an array of size n and an integer k, you have to return the maximum length of valid subarray. So a subarray is valid if each element in that subarray exceeds the value k upon length of the subarray. So for example, let's say we have this particular array and k is 20 and this red box represents one subarray into this array. Okay. So this subarray is a valid subarray or not. Let's check that. So in order for this subarray to be valid, all the elements should be greater than k upon length, right? So the length of this subarray is 4. K is 20. So 20 upon 4 is 5. So all the elements should be greater than 5. But here we can see that this element is not greater than 5. It is 5. Hence, this is not a valid subarray. Now let's check another subarray. So this is another subarray. Here the length of the subarray is 5 and 20 upon 5 is 4. So all the elements should be greater than 4. And indeed, all of them are greater than 4. Right. So this is a valid subarray of length 5. And I have to maximize this length. Okay. So the final output of this test case would be this particular subarray. Here, the length is 7. So 20 upon 7 is 2. Integer division is 2. And all of them should be greater than 2. And indeed, all of them are greater than 2. Right? So the length is 7. So I hope you understood the problem. Okay, so let's check the brute force approach first. So in brute force approach, we'll go through these two steps. The first one is we'll go through each and every subarrays, and second is for each subarray we will verify whether that subarray is valid or not. Okay, in order to verify, we have to go through each and every element in that subarray and check whether that is greater than k upon length of that subarray. Okay, so let's say, okay, we know that there are n square subarrays. So the first subarray would be this, second would be this, and so on and so forth, like up to this element. Okay. Then afterwards, it will start from index 1 and will go to index n minus 1 like this. Okay. So we have to go through each and every subarray using nested for loops, I and j pointers. Okay. And within each subarray, for example, let's say this is one of the subarray. So if I want to verify whether this is a valid subarray or not, I have to iterate through this subarray and check whether it is greater than greater than k upon length of subarray. Okay. So the time complexity for this approach would be n square for going through each and every subarray and big of n to verify whether that subarray is valid or not. Okay. So it would be n cube approach. Now let's see whether we can eliminate one of the n or not. Now we'll try to eliminate one of the n over here. So in order to do so, you have to notice one thing. Here the condition says that all the element of the subarray should be greater than k upon length of the subarray. Okay. Now tell me one thing. First of all, what is the minimum element in this subarray? Minimum element is 5. Now tell me one thing, if 5 is greater than k upon length of subarray, then obviously all the other elements will also be greater than k upon length of subarray, right? Because it is greater than 5. Okay. Hence, what I can do is instead of iterating through all the elements, I'll just use one variable which will track the minimum element in the subarray. Okay, and this is how we can eliminate the one of the n. Okay, I hope you understood this part. So the new condition would be minimum of the subarray should be greater than k upon length of the subarray. Okay, so the new time complexity is n square. But still, uh, in online assessment round, I think we had to solve that in big of n time complexity or n log n time complexity. And this is quadratic, which would give you TLE. So we have to optimize this thing as well. Right. So till now, we were first going through each and every subarray and then checking the condition, whether the condition is satisfied or not. But what if I tell you that we can go in reverse direction as well? So what we'll do is we'll first fix the minimum element of the subarray and then generate the subarray. Let me show you this part. So what I'm doing is first we have to fix the subarray. I mean, first we have to fix the minimum element of the subarray. So I'm saying that I want to know the maximum length subarray where 5 is the minimum element. Okay. So 5 is the minimum element that I've taken. Now, this is one subarray where 5 is the minimum element. This is another subarray where 5 is the minimum element. This is third subarray where 5 is the minimum element, and so on and so forth up till this point. Okay. Up till this point, 5 is the minimum element. If you still expand the right hand side, then 5 will no longer be the minimum element because 4 is the minimum element. Hence, you can expand up till this point. Similarly, you can expand the left side also up till this point. Okay. So this is the subarray, or in other words, this is the maximum length subarray where 5 is the minimum element. Okay. So what I've done is fix the element as the minimum element and then get the maximum length subarray where that element is the minimum. Right. Now, why am I doing so? Because after doing this, I know the left hand side. Left hand side is 5. Okay. Because we have fixed the minimum element. And right hand side is k is also fixed. And we have generated the subarray, maximum length subarray. So now the length of the subarray is also known, which is 5. So 20 upon 5 is 4 and 5 is greater than 4. Hence, this is a valid subarray of size 5. I hope you understood this part. Now you might say that this is also n square approach because first you are basically fixing one element as the minimum element and then you are expanding the right hand side of this window and the left hand side of this window in order to get the maximum length subarray. But you need to notice one thing. See, once I fix this element as the minimum element, check this thing. What is the next small element? What is the next small element of this 5? The next small element is 4. Okay. And what is the previous small element? Previous small element. The previous small element is not there. Okay. Hence, we can expand this window up till this point and up till this point. Okay. In other words, we don't really have to expand the window. We just need to know what is the next small and previous small. If we are somehow able to pre-compute this, then the time complexity will no longer be n square. Instead, it would be O of n. Okay. Now, let me show you one LeetCode problem which you can try to practice. So there is this LeetCode problem, and this problem is basically using the same approach. It also has the, here also we are finding the next minimum and the previous minimum. Okay. I mean next small and the previous small. So you can try to solve this question, and we will be using the same template in the current question as well. Okay. So after that, the time complexity would be big O of n. To be precise, it would be big O of 3n, right? So the prerequisite of this particular solution is this problem. So I highly recommend you to go and solve this problem. Okay, now let's check out the code of the current problem. So here I've taken the same test case that we were working with. I've also taken the same value of k, and I've defined a function max subarray length. Here we are using the same template which is used in the problem that I showed. Okay. So we'll just copy paste that thing over here. And after that, the main logic of this problem is this. We are going through each and every element in the array and will consider that element as the minimum element. And accordingly, we will get the length of the maximum length subarray. Right. And after getting the length, we just need to verify this formula. This formula was minimum element of the subarray should be greater than the k and the length of the subarray. So I have just taken this length on the left hand side, so it becomes multiplication. So once this condition is true, we'll try to maximize the max length variable, and finally we'll return that thing. Okay, so I hope you understood this problem. Let's run this. So indeed the answer is 7, which was the output. Okay. So still, if you have any doubt in the optimal solution, then you can comment down. I'll try to answer this. If you found this video useful, please like the video. Thanks.